My name is Kyle, and I would like to talk to you today about cloud architectures that we can build without using passwords. And before I kind of get started with that, I do want to take a little bit of a poll and see how many, what kind of audience we have today. So how many people here are what they would call solution architects or sysadmins or do something in charge of developing cloud infrastructures? Okay, about half-ish. I see a lot of half hands. I'm not sure if that's what they do. That's all right. So a bit about me. I'm Kyle. I did my PhD at MIT in aeronautics and astronautics, so I actually specialized in space flight and keeping humans alive in space and developing technology for humans in space. And out of that, there was a large focus on how we develop systems for realistic human use, right? We call human factors engineering, or how you develop something so that humans will use it as you intend for them to use it and in a safe manner. And I didn't end up doing that in terms of space, but I did also work in the Computer Science and Artificial Intelligence Laboratory, which is this funny-looking building. But even though it looks goofy, it has some cool stuff going on inside, where I focused more on human-computer interaction. And after that, in 2018, I started my own company, Invicton Labs, where we do a lot of IoT, a lot of cloud development, a lot of security work in terms of both consulting and implementation, mostly for startups, but ranging all the way up to federal governments. And we're based in the beautiful city of Ottawa, which is the national capital of Canada. If you're ever in town, look me up. This might look familiar to some people. We don't do a great job with passwords, right? And anyone who actually is responsible for trying to keep them secure knows that this is a problem. And this is incredibly common, right? I work with a lot of clients, and they often bring me in to try to fix things like this, but this is almost universal. And you can say that we never do this, but well, I don't believe you. Someone does this in your organization. You might just not know about it. But before we get into the details, let's describe in this context, what is a password? And the way I'm defining it for this talk is it's a value that is used to authenticate or authorize with something, and it's provided to the authentication system as it is. So you don't need to decrypt it before you send it. Or it could be something that is used to generate or derive a password that is used for the system, such as the Secure Remote Password Protocol. And it includes a lot of different things that you might not initially think of, right? Of course, you have your classic passwords. But you also have API keys that your system uses, or maybe you give it to your developers so that they can use it for local development, and now they have it stored on their computer. One-time tokens that have a long life, or the kind of one-time passwords that you get sent by email or SMS. Magic links, if you use Slack, which you probably do since you're at this conference, you'll know that they love magic links, but that link itself is a password. Because with it by itself, you can log into an account. And unprotected certificates are also a good one. By unprotected, I mean, this should say keys and not certificates, but that you don't need to type the password in order to use it. So it encompasses a lot of stuff, right? This is a massive category in terms of what we would consider secrets or passwords. And we should talk about how they leak. How do these things get out into the world? And throughout this talk, I mentioned that I do a lot of work in kind of the human systems integration, right? How we develop systems for humans to use, not for machines to use. So we have to be realistic about this. There's a plan, right? There's what your security team wants you to do. Use your vaults, rotate your passwords, 2FA, complex password rules, etc. And then there's reality. There's what your developers are actually going to do. And we all know that is not the same thing most of the time. They will do whatever is most convenient for them. And so as we try to figure out how to solve these problems, we have to design systems that have the least resistance, that the developers or users or whoever is authenticating, they want to use because it is best and easiest for them. So how passwords leak? Well, we have them shared in plain text, right? Our first example, incredibly common, and a lot of things leak this way. But we also have all sorts of other systems. CI/CD, everyone uses it, but it is not bomb-proof. There have been a number of different breaches in this field in the last few years. CodeCov was a huge one. I think they had 29,000 clients whose credentials were leaked out. That was discovered in January of 2021, and it wasn't patched. It occurred in January 2021, and it wasn't discovered until April 2021. That is a very wide window for credentials to be leaked out through a system. Travis CI had something similar where their vulnerability was reported and it wasn't really patched for a while. There was CVE advisories and all sorts of stuff, and it was just a mess. Lots of credentials leaked through these systems. We have password managers, right? We encourage people to use vaults, 1Pass, KeepPass, LastPass, whatever you prefer. These aren't great. Well, they're great, but they're not perfect either. KeepPass had a CVE where they were writing passwords to plain text log files. Anyone who could access that log file can see the credentials. LastPass had a major breach where their developer environment was accessed illegitimately, and a lot of data was able to be exfiltrated through that system. They claimed that no production data was accessed, but do we really know for sure? The other issue with password managers is that they require human intervention in order to use them properly. And this is something we're going to talk about repeatedly, right? The human in the loop. How do we build something so that it actually works when humans are using it? A password manager requires someone, unless you set up some very complex automated systems, to actually remove someone's access or to change and make sure that people have access to the correct shared vaults and the correct shared credentials, and to keep that up to date as people are removed from the company or moved to different departments. And that often doesn't happen properly. We have credentials that are stored locally and never rotated. If you have ever worked with AWS, you probably recognize this file. This is in the format that AWS recommends, right? This is their credentials file where you store your access keys for different IAM users. And when you're in a role such as my own, where you're doing a lot of infrastructure type consulting or development for many different clients, if I used a system like this, my credentials file would have administrator access to at least 20 different enterprise clients and all of their AWS infrastructure. Talk about a target for attackers. You can have your private keys and certificates because they're a secret, right? They're a password. They give you access into your, through SSH into various servers. And most of the time, if we're being honest, because we're talking about humans, they will not password protect their keys. You can ask them to, you can instruct them to, but since it's their keys and you're not supposed to be seeing it anyway, you can't really verify that. So these are things that are stored on their local machines and that, if breached, give access to all sorts of stuff. Then we have, of course, your simple passwords with brute force. These are the ranks of passwords from, I think this was 2021 or maybe 2022, most common passwords that were leaked. Nothing's changed over the years, right? We all know that this has been this way for a very long time. But if you can use brute force to attack something and determine that a password is valid, well, now you can, maybe that user is using that password everywhere else, of course. And so you can retry it in all their different accounts and get access to many different things. And we say, okay, well, we're talking about developers and internal infrastructure, and none of our developers are dumb enough to actually use a password like password, right? They would never do something like that. That simply is not true, and we cannot rely on people to make those kinds of smart decisions when they don't have a lot of incentive to do so, or when no one is monitoring that, or they don't have the correct training to understand why that's so important. Equifax learned that one the hard way. And these breaches, when they happen, are incredibly expensive, right? Because when we talk about user accounts being attacked, my Twitter account is hacked, or my Facebook account is hacked, or whatever's happening, that is my personal account that is being attacked and my data that is leaked, but not everyone else's. But when one of our developers or one of our infrastructure credentials is attacked and breached, well, now they have access to all of our customers, all of our users, all of our internal employees, all sorts of different things. And this is where you get into what we call mega breaches, which is over 1 million records breached. And this cost becomes extremely high, right? We're looking at hundreds of millions of dollars in terms of fines and trying to recover these systems and compensation for the users whose personal data is now out in the world. And we can see several examples of that, right? Two of the big ones. First one being T-Mobile, $500 million in terms of a settlement for this breach they had to deal with. The way this happened, not a whole lot of details are available for it because they keep it pretty tight, but we understand that an attacker was able to access their internal network through a misconfigured gateway that they had, and that gave them access to T-Mobile's test or development environment. And from there, they were able to brute force their way into production systems because, who knows, maybe they had a database password like admin, and they were able to access it from the test environment, even though the credentials for it were not directly stored in the test environment. But you'll note that being able to get and use a password was a key part of this. And here they did it through brute force, but it could have been many other ways. Equifax had to deal with a $425 million settlement. And here, there was a vulnerability in an Apache Struts deployment they had not patched out yet, and so the attacker was able to achieve remote access to that server and its internal systems. And from there, they were able to find and utilize database passwords that were stored and accessible to that system. And again, not a lot of details. I don't know if they were stored there in plain text or some environment variable, how it was accessed. But again, they were able to get a password and use it for the attack. And they were able to load a bunch of data out of that database and then exfiltrate it out through that server. So when we talk about the risk of these things happening, it's really the product of the probability of something happening and the impact if it does happen. So if we want to reduce our risk, we have two different ways to do that, right? We can reduce the probability of it happening, step one, which is we use passwords in fewer places, right? If there is no password for them to find, they cannot get our password and use it against us. We want to store our passwords in fewer places. It's great if you only have one password in your system, but if you give that password out to 50 different developers so they can test locally, well, now that's 50 different places that it can be breached. And we want to use short-lived passwords because that reduces the chance that any credential that they are able to obtain is still active. And to reduce our impact, we want to start using the minimum permissions models, principle of least privilege, and to monitor for any breaches to detect them early so that we can respond immediately and deal with it appropriately. And here also using short-lived passwords is great because it will reduce the time window where someone can use your breached credential to attack you. So in summary, throughout all this, passwords are risky, we want to minimize the use of them, and if we do have to use them, we want to minimize their scope. Things that I think everyone here should probably already knows because it's common sense, but maybe this drives home how important it is. So when we're talking about authentication systems, there are really 5 common factors that we can use to authenticate someone. We have knowledge, right, the password that you know, or the security question that you know the answer to. Possession, right, so having something that can prove that it is that item, so an MFA device where you've loaded your time-based one-time password system onto it, or a certificate that you have on your machine. Something that is inherent to your user. Those are your biometrics, right? My fingerprint is inherent to me. Location, often defined through your IP address, because that's really all we can use in terms of identifying someone's location on a network. And behavior patterns. So this is along the lines of, user A only generally logs in at 9 a.m. when they get to work. They log out at 5 p.m. when they leave work. Someone's logging in at midnight. That's kind of weird, and maybe we should require extra verification for that. But of course, in the modern era, most of our developers want to be working on a beach in the Caribbean, and so we can't really use location anymore. It's simply not a great factor in the modern era. You can try it, but it's going to cause a lot of friction in your environment. And as we identified, anything that causes friction is something that won't be used properly. So, of course, our most common today, we use knowledge, a password, in combination with possession of some sort of MFA device. And here, we're going to talk about how we can change that to instead use an inherent characteristic, biometrics, with something you possess, and get rid of passwords altogether. And we have a lot of progress in this field. There's a number of tools that are now available to us to actually accomplish this. Also, Windows Hello does all sorts of biometrics, Mac Touch ID, Fingerprint ID, the FIDO Alliance with web authentication, and a number of other tools that are available, such as security keys. But we're going to focus on FIDO because it's the new cool standard that everyone is adopting. The original FIDO started out with FIDO U2F, Universal Second Factor. It was only for second factor authentication. It was specifically a physical device, like a security key. It's kind of where the YubiKey started out, and only available for second factor. It could not replace your primary authentication factor. So it replaces that one-time password that we currently use, or at the time was most often sent through a text message or an email that you had to copy that code into your login. And at the same time, we had FIDO UAF, and then later on, we have FIDO2. And those are your fully passwordless systems where you actually can use biometric authentication to use it as your primary authentication mechanism. So it actually replaces the password altogether. And what's great about this is that it's not limited to 2FA, right? It can be your primary factor, and it can also do second factor. So it's quite intercompatible. We're not really going to talk about UAF because it was kind of an early standard that didn't generate any traction, and we don't deal with it anymore so much, and we've moved on to FIDO2. So that will be our focus. A quick review of FIDO2 for anyone who's not overly familiar. There are really three main components to it. First, you have your WebAuthn API. And when we talk about this, there's often a lot of confusion, like what do you mean by API? It is an API, a JavaScript API that browsers offer to you to use to implement your system. It's not an API that you implement on your server. It's not an API hosted by the FIDO2 Alliance somewhere. It is just a JavaScript API in your browser. Your second component, and this is the CTAP, we call it, the Client to Authenticator Protocol. This is the system that allows you to use some external device, such as my phone or YubiKey or some other security key, to be able to use that device as the authentication mechanism on my platform, which would be my laptop or my desktop. This is primarily if you don't have like a fingerprint reader or an infrared camera on your laptop, you can use your phone as your biometric authentication. And then you have your actual FIDO authentication system. That's once you have generated your public keys and your browser has it, how you send it to your authentication server, store it, and then use it later on. So the original FIDO specifications were from 2014. And they did generate some traction, not nearly as much as they had hoped. And there were some problems with, right? People don't like carrying extra stuff. Right? If you have to carry a security key, not a lot of people are going to use that system when they, half the time, if they forget their key at home, they can't log into their laptop or any kind of web authentication system. That's a problem. So that was a major limitation. There wasn't a lot of support for biometrics. Infrared and 3D cameras weren't common in laptops or desktops at the time. And the developers to use these systems said, well, if I need a password anyways, and this is just replacing my time-based one-time passwords, is it worth the effort? Not particularly. Didn't get a lot of adoption. But then FIDO2 comes along 2018, and we have all these cool convenient features, right? Convenience. Humans want convenience. So we now have a complete replacement for passwords. And we now have laptops and phones that have biometric fingerprint sensors, Face ID, and we can start using all these biometric systems to log in instead of a physical security key that we could forget in our other pants. And we have support for this through the major operating systems, Windows Hello, Apple Touch ID, Face ID, et cetera. And there's now better support through CTAP2 for using external authenticators like your cell phone to be able to log in. And so in our chart here, which unfortunately has the most recent data I could find, we can see that around 2018, when this is released, we start to see a pretty substantial increase in the adoption of biometric authentication. And that, I believe, is due primarily to the adoption of FIDO2 in a lot of enterprises. Now, we're starting to see adoption for this in a lot of end-user, I shouldn't say a lot, in some end-user applications, right? So here I can log into my GitHub account. I still have to use a password to log in, but I can use my WebAuthn for my second-factor authentication instead of a time-based one-time password. And on the other side, I'm using Windows Hello to log into my password manager. There's something a bit ironic about using a passwordless system to log in to access my passwords, but they're adopting it, right? We're starting to be able to use these technologies. So now we're going to go through kind of a common architecture stack that we see in as cloud engineers and the types of systems we might need to build and some of the issues with it in terms of security. So generally, you want to start with an identity manager. You need some way to track your users. So Azure Active Directory, Google Workspace are kind of the two big ones these days. Usually includes your email services. You log into it with an email and password, most commonly. Hopefully, it requires 2FA. And everyone says, of course, in a secure environment, that's going to require 2FA, but it doesn't really. not in most environments. Enterprise customers, 22% are using 2FA in Azure AD. That's a very low number for 2022. In our cloud system, we're going to have some sort of user credentials. So here we have AWS IAM users and their security keys. This is that AWS credentials file that I showed you near the beginning. This is where those keys are generated and tracked. So these are long-lived tokens, right? This is a key that has no set expiry date. And they have expansive permissions most of the time because you don't want to have to track 20 different users with 20 different security keys for different types or different permission sets. And even if you did, it doesn't really matter because they're all stored in the same file on your computer anyways. So instead, we usually have admin ** for your permissions for these keys because that's just easier. That's the more convenient route. And they're stored locally, of course, which means if anyone gets into my computer, they get into my entire cloud infrastructure. We also usually have a VPN. And this most commonly uses a username and password or a certificate to log in. Either way, that's a long-lived secret, right? Because password certificates we talked about, they're not commonly rotated and they can be breached. And most organizations don't actually handle certificate revocation properly because it's relatively complex to set up when you're working with many different systems that might use these certificates and you need to track this revocation across different applications. We're going to have a database, of course. Here we're going to use MySQL for an example. Your passwords for this, well, they could be rotated, of course, but realistically, who's actually rotating their passwords on a regular basis for their database users? Because they're often not rotated, they're therefore long-lived credentials. And the other issue is that most of the time, a single database user is shared across many different applications or services within an infrastructure because it takes time and effort to create multiple different users and properly scope their permissions to different tables and rows based on what they're actually using. So instead, we create one user that can do everything and just share it across all of the applications. It's what's most convenient. We're going to use GitHub for our code repositories and for our CI/CD, GitHub Actions. Again, these are long-lived passwords because particularly with GitHub, organizations usually invite personal users into their organization, which means that the owner, the individual, is responsible for their security policies. And there are certain policies you can set. You can say that in order for a user to join this organization, they must have 2FA enabled, but it doesn't give you a whole lot more control than that. So you're really relying on the individual developer to keep their credentials safe. And therefore, it is outside of the organization's control in terms of that aspect of security. And this is much more sensitive than it's often considered to be. Because we could say, okay, we have the intern who has access to the development branch or feature branches of our front-end interface. And we say that that's not a huge security risk. But now that person's credentials are breached, some attacker gets access, and even though they can currently only access our development environment or create pull requests, that gives you all sorts of ability to inject malicious code that you will hopefully catch with a code review, but who's doing a thorough code review of every single line that is changed in every commit? There's no way to make sure that actually happens, and realistically, not all of your developers are really doing such a thorough code review. So you can promote this malicious code through up into production, even if you only have access to the development environment. And that's not always going to be the case, right? That's not always going to be possible, because maybe you do have great security protocols. But if an attacker manages to do that with 20 different organizations, some of them are going to get through. And this also gives you full access to your CI/CD system, or I should say, if your developer account has access to that system, that gives you all sorts of power over things. Because now, as some previous talks have discussed, particularly if you're at the GitHub Advanced Security one in the last session, there are a lot of secrets stored in CI/CD. You can do all sorts of malicious things with them, send them all over the place, and it's really hard to detect. Talking about your GitHub Actions, you usually have to store a bunch of secrets in there. In order to deploy these systems through your workflow into AWS, you need those access keys, right? Those long-lived credentials, and you have to store them in those secret environment variables. Now, these have multiple different problems. They're long-lived. You'll note that that's a very common point here. But they're also easy to leak. Again, if you've seen the other talks about this, you'll find that these things are leaked all over the place through different actions that aren't taking care of them appropriately. And they often have extensive privileges. If you've worked with IAM in AWS and the equivalent in Azure or wherever you do it, you'll note that it's actually quite difficult to do that minimum scoping of these users because AWS and Azure don't really publish the specific permissions that are needed to do all sorts of different actions. So you might get it working to create your API, but as soon as you try to delete an endpoint, you'll realize, oh, it doesn't have the delete permission, and now we need to add things. And so to avoid this time and this effort, we just give it * permissions, and it can do whatever it wants. So these are usually very sensitive credentials. And they're also relatively hard to rotate, because as soon as you need to manage credentials stored in multiple places, trying to rotate those and keep them synchronized and to deal with situations where you've rotated them, but a workflow started before you rotated it but hasn't finished until after you've rotated it, trying to manage that and catch those edge cases can be quite a bit of work. And it's also hard to trace when there is a problem because this is an automated system. So who actually caused these problems? Is there a malicious actor in our organization? We don't really know. It's very hard to track down. But that's just how it is, right? We don't have any other choice because we have to use these types of technologies for our infrastructures, and I disagree. That is how it used to be, and we have better options now. So what we're going to do now is go through that entire stack again, but this time we're going to talk about how we can do it without using a single password anywhere in that entire infrastructure. And there are a couple of core principles we're going to adhere to. We're going to have a single source of truth. So one place where users and their permissions are defined, nowhere else. We're going to use group-based permissions. Nothing is ever tied directly to a user, it's tied to a group, and users can be associated with one or more groups. Passwordless everything. We're not going to use any passwords in our system. So we'll start over with our identity manager. In this case, we're going to use Azure Active Directory, and we choose this for two reasons. One, because there seems to be more of a Microsoft crowd at this conference, but two, because it supports passwordless authentication for end users. And you can see that in the red box in the image. You can log in with WebAuthn, FIDO2, and use a security key or biometrics to log in without actually typing in a password. I should note that Azure currently supports this. Google has announced that their Workspace product will support this at some point in 2023. So that should be coming soon for Google users. And you can log in with your fingerprint, with a FIDO device, right, a security key, face recognition, basically whatever you choose to allow and what your user prefers. It includes all the things you want from your identity provider, email, calendar, et cetera. Google's coming. And for AWS, instead of creating IAM users, we're going to use an identity provider. And this allows you to set up access to AWS using SAML or OIDC. So you can specify that your Azure AD configuration will be your federated external identity provider. And this allows you to create IAM roles with trust policies. And you can say that, okay, here's a role that has all these different permissions to do whatever I need to do in AWS, and I will allow these specific groups in Azure to assume this role. And so that role can only then be assumed by users who are in those groups. Now, generally, this is an IDP-initiated flow, which takes a little bit more work to set up your portal for it, but it works just fine. This is kind of the older style of doing this for AWS. But it allows your passwordless users in Azure to now have passwordless access in AWS. And related, Amazon now has their newish product called Identity Center, which you may know as AWS SSO. And it is essentially just a wrapper for the identity provider plus roles, and it manages some of that for you through what they call permission sets. It definitely has a much improved UI, and it allows that SP-initiated login flow. But it requires you to provision all of your users and groups from your AD into AWS's database. And that is both a fair bit of overhead to set up, but it's also a bit of a security risk. And this is something I've actually confirmed with AWS representatives as a security risk, and they say, nothing you can do about it. So the issue here is that if you set up this automated sync and it fails for whatever reason, maybe one of your tokens expires or there's some sort of network issue, or Amazon's US East 1 region fails, which we know never happens. Happened like 3 times last year. And that sync doesn't happen. Then if you make a change in Azure and you remove someone from a group, but you don't remove their user, so they can still log in as their user, they can still get a token that proves that they are that person, but they shouldn't have access to things. If they log in through this system, then Amazon will recognize that user, look up that user in their internal Identity Center database, and see that because that sync hasn't happened yet and they haven't been removed from that group in Amazon, that they should still have access through that group. So that's a bit of a risk, so just keep that in mind as you're using these systems. We're also going to have our VPN, of course, but here we're going to use Amazon's VPN client. This is based on OpenVPN. They've done a lot of customization to it to add other features, but it allows us to do our authentication through an IAM identity provider or through Identity Center, basically the same thing we just talked about for our AWS users being able to log in. And you can also configure it to set up authorization rules, which are basically network rules saying that you can access these CIDR blocks. You can link that to different user groups. You can say that my AWS administrators group can access the entire network, whereas my backend API developers group can only access the development subnets, for example. And you can configure those rules based on their membership groups in Azure. So all you need to do, change their group association in Azure, automatically propagates through, and now they can only access the subnets that you want them to access. It's passwordless, because when you try to log in through this VPN client, it just opens up a browser with your Azure SSO login. And that was passwordless as well, as we identified, so now you can get into your VPN without a password. We're also going to have a database. Again, we're going to use MySQL, but we're going to do it through Amazon's RDS service. And what they support through this service is IAM authentication. And this is exactly what it sounds like. Using an IAM user or role, you can access a specific database user in RDS based on a policy that that role has. And this allows you to set up those policies based on the same things that we talked about for everything else, like the VPN, right? You put trust policies in those roles that say that certain Azure groups can assume those roles, or if your application is trying to connect to the database, that the role that your EC2 instance or your container is running as can access that database user. And so because Identity Center uses Azure AD with passwordless users, our database now has passwordless users. And what's neat here is that you can have as many different database users as you want, and you can configure, essentially you configure your database users as you normally would, but you don't specify a password for them. You specify that you're going to use the RDS plugin for IAM authentication, and that's how Auth is handled. And then in your IAM policy, you just specify a permission that says database connect, and then on the resource, you specify the name of the user that you, or the database cluster ARN and the name of the user you want to connect with. And then you can have as many different users with it, and have each policy able to log in with any subset of those users. And the way this works internally is your application will call the AWS API to generate a very short-lived token for that user, and then it uses that token as the password to connect. So there's no secret that's actually stored anywhere. It's generated at connection time. You should also note, though, that it does, because it's so short-lived, if you have a connection pool that continues to establish connections over time as they open and close, this does need to be dynamic. So your connection string needs to be dynamically generated each time you connect, because those tokens only live for a couple of minutes, right? And a lot of libraries offer those kinds of hooks or callbacks to be able to dynamically generate your connection string when the pool is trying to open a new connection, but it is a bit of development work to set up. For our code repositories, we're going to use GitHub again, but now we're going to use GitHub Enterprise because it supports SSO through SAML, so we can now configure this with Azure Active Directory, as with everything else we're doing. In case you haven't noticed, single source of truth is our Active Directory, our user directory. And it allows us to set up repositories and CI/CD workflows and to grant access to those based on membership in groups. So we could say that our backend developers can access all of our different API repositories and modify the workflows, et cetera, and all of that is controlled from one central place. No password required to do this because it uses Azure, which is passwordless. For our secrets, now this is possibly my favorite thing here, and I've seen it come up in one or two talks at the last few conferences, so it's getting some traction, which is great. For GitHub, I think it's only a year since they've released this, so it's relatively new. But it allows you to generate a GitHub signed token, which includes a bunch of information. So this uses OAuth and it includes claims for the repository name, for the branch, for the tag, et cetera. So when a workflow runs, it includes all of this data in a token that is accessible in a secret in the workflow. It's not a secret that you have to store manually in secrets. It just generates it at runtime. And then you can create an IAM identity provider with OIDC. And you can set up that policy for that provider to trust GitHub's keys for signing those tokens. So now you can create IAM roles. So I could have a role named front-end workflow development. And I can set up a role for that. And in the trust policy, I can say that any token that has a claim for it being this repository, so the front-end repository and the development branch, is now allowed to assume that role. And AWS has a GitHub action on the marketplace that you can use to actually create a token, a temporary STS token using this system. And now your GitHub runner can now access those IAM roles without having to store any kind of credential at all in GitHub. And this is a fantastic way to eliminate secrets altogether from GitHub, because not only can you use this to access AWS resources and APIs, but you can also now store your secrets in a centralized vault, like in AWS Secrets Manager or System Parameters or Azure or Google's equivalents, and load them at runtime when your workflow actually runs, so you don't need to store them in GitHub. And as we talked about, one great way to reduce the probability of a breach is to reduce the number of places that a secret is stored. And this was cool enough that I went ahead and built a Terraform module for it. So if you want to see how to do it in practice, you can check that out. It's not the only one. There are a number of modules that do this, but I had a fun time building it, and it was a great experience to learn about it. So in summary, we now have a passwordless architecture that supports identity user management, supports a VPN, supports our databases, supports code repositories and CI/CD workflows, and there isn't a single password anywhere in that infrastructure. This extends to most services in AWS, at least. I'm not as familiar with the other cloud providers, but almost all of their services you can set up using these types of mechanisms, role-based access with identity providers through OIDC or SAML through your central user management system. There are some old legacy systems that still require passwords, but I believe those are being phased out over time. And every bit we can do to remove passwords is great for security. So now we'll touch on selecting vendors, an ongoing conflict of interest, which not within our companies, but between us and our vendors. Because when we have to use third-party systems, such as selecting GitHub or selecting other password management systems or whatever you want to use, there are things we have to keep an eye out for and look specifically for when we choose them. First off, we always want them to support SSO, right? So SAML or OIDC, very important components for login if we don't want to have to add another layer of usernames and passwords to our system that we have to keep track of and maintain over time. And we also want a system that supports role or group-based permissions instead of user-based permissions, because anytime a permission is attached to a user, that's something you just have to track over time and remove it when it's no longer relevant. And we're looking for providers that offer all of the security features at no extra cost. And the reason I say this is because security, to me, is a shared responsibility, right? It screws all of us over when there's a breach, us and our vendors, and so we should all be working collaboratively on this in order to minimize the risk of that happening. So the flip side is things to avoid, well, no SSO support, user-based permissions, or services that charge a premium for security features. There's actually a website that keeps track of this. I think it's called SSO Tax. And it's just a public shaming forum for all the companies that charge extra for something as simple as SSO. And we can see how this kind of takes form in a lot of different companies. I love Terraform. I use it for most of my infrastructure. Terraform Cloud is something that I tried out a couple times and was all right. But a couple things to note here. So they have a free package, right? You can use all their systems and have unlimited users and repositories or workspaces for free. But what they start charging for is team management. So if you use the free package, every user that you have in your organization is an administrator. And there's no way to reduce those permissions to anything less than administrator. and they're an administrator on every workspace that you have in that organization. So to add that kind of team management, which is a basic security feature, now you have to move into the paid package. Try to convince your management that you need the paid package just for security and not for any kind of performance reason. The other thing is we have SSO, a very common and free feature for vendors to implement. Like, it costs them nothing to implement an SSO system because they're actually outsourcing all of the work to some other company. This is under the business package. And if you've ever had to click that contact sales button, you know that's not a button you want to click if you can avoid it. So when there's no other option, of course, if you have to use a password, always use your two-factor authentication. I think it's 99.9% of attacks that would have succeeded without it are blocked by two-factor authentication. It is the most effective way to secure your system, or to reduce the risk of attacks on your system with the lowest cost overhead to implement it. Rotate your passwords if you can. So a lot of vaults and tools have this built into them. AWS Secrets Manager, for example, will do this for you for certain types of passwords. You can also write custom code to do it yourself for any type of password you like. Randomly generated passwords, of course. Nothing that's ever going to show up in a dictionary attack. And then keeping tokens for external services in vaults that are only accessible by your applications, right? Do all of our developers actually need the Datadog API key? Probably not. Not if you set it up in a way that excludes that component for local testing. And you want to make sure that they're loaded at runtime and not stored somewhere permanently, because everywhere that you store a password is somewhere it can be stolen. So if we eliminate it from our environment variables, our configuration files, anything that is static, and load them at runtime, not only is it easier when you need to rotate them, but also it's one less place it can be stolen. And if it must be shared, then password managers are still our best option as far as that goes in terms of multiple users being able to share one password, like an AWS root account, email and password. Now, after the last time I gave this talk, afterwards someone came up and said, well, that's cool, but like, what if someone steals your fingerprints? And that was a great question, right? And so I've added this for this talk to talk a bit about the limitations of biometrics, because nothing is perfect and this can happen. So hacking fingerprints is actually relatively easy to do. This was an article where Kraken Labs managed to fool Mac's fingerprint ID sensor just by taking a fingerprint, I think it was off of a glass or a screen or something, and then creating a copy of it with glue. And they do have like a liveness sensor to check that your fingerprint is alive, but if you put the fake fingerprint over a real finger, it apparently passes. I'm not sure if this one's been patched or improved yet. And for Face ID, this was one from CyberArk that they published, and there's actually a CVE for this for Microsoft's Windows Hello system, where they managed to bypass the Face ID, or the face recognition in Windows Hello, by creating a custom USB camera that only sent one IR frame, infrared frame from a camera, and then it actually succeeded. So it didn't require any kind of liveness testing. And they were able to capture the infrared frame that they sent through the system from a completely separate source, like a camera in an elevator or a security camera or anything like that that has IR capability. So there are risks here. This has since been improved a bit. Microsoft implemented a system where now the actual cameras that are approved to be used with Windows Hello face recognition have to have a certain security key, and they have to be signed, and trying to prove basically that you're not building a custom camera to do this. So it's improved a bit, but it's still a risk. But your question becomes, is it more likely that my user is going to write down their password on a sticky note on their desk because they can't remember it, and that's going to be stolen? Or that someone's going to set up an IR camera in an elevator to capture their face and then create a custom camera to use that with their laptop to log in? So when we come down to the realism of it, this is still far more secure than using passwords. But it does raise the question, why not both? Why don't we use all of these systems, right? And that is possible. And I have coined this Extreme Auth, trademarked, don't steal it. There is no reason that you can't have a login that uses a fingerprint using WebAuthn on your first device, and then requires Face ID with WebAuthn on a second device, and then a password PIN on a third device, and then an email confirmation code, and then an SMS confirmation code, and then a security question like, what's my mother's maiden name? You can totally do this. There's no reason you can't do this. If you're using something that's fully customizable like AWS Cognito, this would take me maybe a day to set up this entire flow. And it will work, but the question is, what are your developers going to do? They are going to find every possible workaround they can, every hack they can to not have to use your silly extreme auth login system because it's not convenient for the human. And so I will leave you with that note that anything you develop in these systems, you always have to think first about the humans who are using it and what they are realistically going to be willing to use in order to log into your system and access your services. Otherwise, it's not going to be used and it defeats the entire purpose. So with that, thank you for your time. I'm Kyle. That's my email. Feel free to email me about anything about this if you want to chat or learn more about some of these technologies. And I'm supposed to remind you that there's a bin in the hallway for cards to rate the talk. And I'm happy to take any questions that anyone might have. Question?
Yeah, so you use here Azure as your authenticator, and that's where you kind of put all your trust. If I go back a while for myself, I use a password manager, and I started by separating out so that I create individual accounts with passwords in each site that I use. I don't use like Google or Apple or something to do that, tie that together for me, because it was so convenient to do it, and I didn't have to trust a third party to keep track of it. But then I started adding a security key, and maintaining the loss of a security key in all these different sites compared to doing it in one place is quite annoying. So how would you say that compromises? Should I put, is it worth more to put all my trust in one of the big five for authentication, or should I try to keep it separate?
It's a great question, and there is no straight answer for it. My argument is usually that what is quite secure, maybe not perfectly, but what is quite secure while still being convenient for the users is usually the best option. So you could say that, okay, well, using a different security key for every website is fantastic, or my own personal security key with a different login for each website is very secure. But like you said, you lose that key, it's incredibly inconvenient, and now what are your users going to do instead? Something much less secure, realistically, right? Whereas you can trust Microsoft or Google or AWS, and there might be an issue with their code, but realistically, given that it would completely decimate Microsoft if that happened and all those enterprise customers were breached, I think there's probably a lot more effort, development effort and time and money going into keeping that secure than we could possibly implement ourselves in some other system. So I generally trust a single source of truth. The other aspect being that it's not just about securing your password, but also being able to manage permissions from one central source is incredibly valuable in terms of a security policy. So there is added value for that feature as well that I think weighs the balance in that favor. Yeah.
You suggested that you outsource your identity management to another system. What if you don't trust them? So, for example, if your application is designed to interface with a third-party provider, but they're not using best practices, they're not using two-factor authentication, how can you build trust into a system where you're outsourcing that?
Right, so the question is, I'm talking about outsourcing all of your security or identification to a third-party provider. What if you don't trust a third-party provider? What should you do? Well, I think to clarify, are you talking about the identity provider, which in this case was Azure Active Directory, or the relying party, which was like GitHub Enterprise?
The former.
Azure. Yeah. Well, if you don't trust them, you shouldn't use them as your identity provider. I think that's the simple answer. Yeah, they have access to everything, and so you certainly shouldn't use them if you don't trust them. You can roll your own. There are multiple open source frameworks and proprietary frameworks that you can use to run this yourself. And because all these wonderful things like SAML and OIDC are all and FIDO2 are all open source standards, you can implement all of those standards to do this entire same workflow using a self-hosted identity provider. So yeah, you can do the whole thing, the entire infrastructure using your own identity provider if you don't trust anyone else. Any others? Okay, thank you for your time.